Determine the radius of convergence and the interval of convergence. Our example is the sum from n equals 1 to infinity in bracket minus 1 to the power n times n over 5 to the power n. Open bracket x plus 2 close bracket to the power n. Now solution. But before solution, we are recalling the formula of the power series. The sum from n equals 0 to infinity an open bracket x minus c close bracket to the power n. Now we compare our formula and our example. We can see an equals in bracket minus 1 to the power n times n over 5 to the power n. And c is minus 2. C is the center of power series, and it's important to understand why c is minus 2. In formula we have x minus c. In example we have x plus 2 minus c plus 2. Minus c is 2. Because of that, c is minus 2, not plus 2. It's important, c is minus 2, not plus 2. Now we need the formula of radius. We know two formulae. First, r equals limit as n tends to infinity, absolute value an over an plus 1. And second formulae, r equals limit as n tends to infinity 1 over the nth root, absolute value an. Now I calculate nth root of absolute value an. Nth root absolute value minus 1 to the power n times n over 5 to the power n. We have absolute value. Because of that, minus, sign minus disappears. N is positive, 5 to the power n is positive. Because of that, absolute value, the sign absolute value is not necessary. We have n over 5 to the power n. And now we have quotient. The nth root of n over the nth root 5 to the power n. Denominator is 5. Numerator is the same. We come back to our formula, to this formula. And in this place, we substitute our calculator. We have r equals limit as n tends to infinity 1 over the nth root of n over 5. And I write 1 over 5 equals 5. But in this place is 1. Why? Because I use this formula. limit as n tends to infinity, the nth root of n equals 1. And now I draw number line. For example, the center here is -2, and now I add 5. -2 plus 5 is 3, and I subtract 5. -2 subtract 5 is -7. And now again I draw a number line. -2, 3, -7. From this I can see my interval of convergence is -7, 3. I have -7, 3. In this place we might be tempted to finish our calculating, but we must check convergence at the endpoints. Very, very important. I substitute -7. I write the sum from n equals 1 to infinity, -1 to the power n times n over 5 to the power n, and in bracket -7 plus 2 to the power n. I obtain -5 from this bracket, and I simplify. Finally, I obtain the sum from n equals 1 to infinity n. My an equals n. This is not important because it was mistake. And now I use vanishing condition. Limit as n tends to infinity and n equals limit n as n tends to infinity equals infinity. It's obvious. And it's obvious it is different from 0. It means when x equals -7, our power series is not convergent. Now I check what happens when x equals 3. I substitute 3. In this bracket I have 3 plus 2. I simplify. Finally, I have the sum from n equals 1 to infinity, -1 in bracket, times n. My an is -1 to the power n times n. And now I calculate limit, and I obtain plus minus infinity, because when n is even we have plus infinity, when n is odd we have minus infinity, but it's not 0, it's different from 0. Our interval of convergence is -7, 3. -7 and 3 are not elements of this interval.